All right. It is working. Okay, so we are going to do a couple of questions dealing with ratios. So let us start with those. Okay, so the question that I want to start with is as follows. This is from the old textbook, page 141, and the question that we're going to do is question number 4. Question number 4. And the question is as follows. It says Mars has a radius and a mass. Mars has a radius and a mass 0.54 and 0.11 times the radius and mass of Earth. So mass of Mars and radius of Mars is 0.54 radius of Earth and 0.11 mass of Earth. So far so good? Okay. So this is radius Mars. This is mass of Mars. This is mass of Earth. And this is radius of Earth. Okay? The question is, if the force of gravity on your body is 600 newtons on Earth, so Fg Earth is 600 newtons. Okay? Then, what is Fg on Mars? What is your weight on Mars? Now, one way of doing it would be to figure out, oh, Mars's gravity is about 3.4 meters per second squared, so 3.4 times whatever your mass is, and you can figure it out that way. But that's a cheating way, right? So I want you to do it. What if you did not have any of these pieces of info? Could you go about solving it? And the answer is yes. Okay? So this is how we do ratio questions. So the first thing that I'm going to do is I'm going to say FGM, weight on Mars, divided by weight on Earth, which equals to big G, mass of the object, mass of Mars, divided by R of Mars squared, divided by big G, mass of object, mass of Earth, divided by R of Earth squared. Okay, so we're taking the weight of the object on Mars, the weight of the object on Earth, then big Fg, which is our force of gravity. Okay, mass of object times mass of Mars. Now we don't have mass of Earth, we don't have radius of Earth, we don't have mass of Mars, we don't have radius of Mars, we don't even have G on Mars. Only this is given. So you're saying, how would I go about solving it? So the first thing I'm going to do is I'm going to sub this in here. And then I'm going to sub this in into here. Okay, so you end up with FGM divided by FGE, which equals to GE, mass of object, 0.11 mass of Earth divided by 0.54 radius of Earth squared. Radius of Earth squared divided by big G, mass of object, mass of Earth divided by radius of Earth squared. So far so good? Any questions so far? Do you understand what we did? Okay. Okay, let's continue. Are we good? So now, as you know, that when you have one fraction being divided by another fraction, so if I had a over b divided by c over d, I would go about doing it as a over b times d over c, correct? Reciprocal. That's the same thing that we're going to do here as well. Okay, so what we're going to do is big G, mass of object 0.11. Actually, let's do it at where we have more space. So big G, mass of object 0.11, mass of Earth divided by 0.54 radius of Earth squared, which equals to RE squared divided by, or times I should say, not equal to, okay, divided by G MO ME. Okay. Now when you do this, what you have to do at the bottom here is when you have 0.54 and it's supposed to be 0.54 RE squared outside. It's like this. So this whole thing is squared. It's supposed to be outside like this. Okay, so what you're going to do is you're going to square both of them. You're going to square this and you're going to square that because the 0.54 is missed. Okay, and when you end up happening is you get RE. Okay, let's rewrite it again. So it's going to become G, mass of object, 0.11, mass of Earth, divided by 0.54 squared times RE squared times RE squared divided by big G MO mass of Earth. And now you could see you can cancel values out. Okay, so G and G cancel out, MO cancel out, ME cancel out, RE squared and RE squared cancel out. Are we okay so far? Okay, and what we do next is we will now plug in those values and solve for them. Okay, can I move this up? Do we understand this so far? Okay, so I'm going to end up with the following. So I'm going to have FGM divided by FGE, which was 600 newtons, which equals to 0.11 divided by 0.54 squared. So FGM, which equals to 0.11 divided by 0.54 squared times 600. And what do you get for your FGM? 226.4 newtons. And this is the ratio question. This is the weight of object on Mars. Okay, are we okay with this? Kind of. So we've solved it without needing the values for most of those variables that were there. There's a algebraic way of solving it. Are we okay? Okay. Any questions? Can I erase this? Now what we're going to do next is the quiz questions, 2 questions from the quiz. Okay, so here we go. This is quiz question 1. And the question was as follows. It said, Mr. Patel places an electric fan at the front of the classroom to cool off his students. They are feeling the heat because they were writing an extremely tough test, which is on Monday. Determine the frequency of rotation of this electric fan if a spot at the end of one fan blade is 20 centimeters. So R is 20 centimeters, which is 0.2 meters. Okay. And has a centripetal acceleration, AC, which is 250 meters per second squared. And we are looking for the frequency. We don't know the frequency. So what we'll do is, again, AC equals to 4 pi squared R F squared, 250, which equals to 4 pi squared, 0.2 times F squared, so 250 divided by 4 pi squared times 0.2, which equals to F squared, square root it. And what do you get for your F? What do you get? .63 hertz. And that was it. That's all you had to do. That was question number 1. Alright, so the second question was mass was 200 grams, radius was 1.6, and the question said that this was whirled in a vertical plane, and we're looking for the minimum frequency of rotation and what is the maximum tension in the rope. So if I have my object like this, and we said Ft is this way, Fg is this way, and for the bottom Ft is this way and Fg is this way. So what we said was, if my object is moving at a minimum velocity, then what is 0 at the top? Ft is 0. So my tension at the top is minimum when I'm moving at a minimum velocity, and that minimum being 0. So Ft plus Fg, which equals to 4 pi squared mr F squared. Okay, so this is 0. That's what we're saying, minimum velocity. If it's a minimum velocity, your tension is 0. Okay, so you get mg divided by 4 pi squared mr, which equals to F squared. M and M cancel out. So F equals to the square root of g over 4 pi squared r. And F equals to square root of 9.8 divided by 4 pi squared times 1.6. What is your F? What do you get? What? 0.39 hertz. Okay. So that was the first one. Now part 2 of the question said, what is the maximum tension? Now as I said, that the tension is at the bottom right here. So it's going to be Ft minus Fg, which equals to 4 pi squared mr F squared. Again, we're looking for tension. So Ft equals to 4 pi squared mr F squared plus mg. Okay, so Ft equals to 4 pi squared m, which is 0.2, r, which is 1.6, f 0.39. So if you had messed up on part A, you would have got part B incorrect. Plus 0.2 times 9.8. And what do you get for your Ft max? Which is at the bottom of the circle. What do you get? How much? Is that right though? Are you sure? Can you redo the calculations for me, please, quickly? .88. How come I remember something different? 3.92.